Alright, so here's example 3. A random number is selected from the set 1 to 29 and 30. So it's the set of all natural numbers from 1 to 30, both inclusive. Find the probability that the number is a perfect square, a prime, a multiple of 4, and a number that divides 2021. Let's start off with part 1, or part A. So we can list the perfect squares from the set, which are 1, 4, 9, 16, and 25. So there are 5 perfect squares right here. So therefore, our probability that it is a perfect square will be equal to 5 over 30, where 30 is the number of elements in the set, which can be simplified into 1 over 6. For part 2, similar thing, we can write down the primes in this set. So we have 2, 3, 5, 7, 11, 13, 15. Oh, sorry, no. 15 is not included. 17, 19, 23, and 29. So there will be 10 total prime numbers in this case. Okay? And then similarly, we can write our probability that it is a prime to be equal to 10 over 30 or 1/3. For part 3, we can again write down the multiples of 4 from the set. We have 4, 8, all the way up to, let's see, 28. Here we have 7 total multiples of 4 from our set. Therefore, our probability that it is a multiple of 4 is equal to, let me just write that neatly. That will be equal to 7 over 30. Finally, for part 4, we can write the factors of 2021 because the question is equivalent to saying that the probability of that number is a factor of 2021. Notice that the factors of 2021 will be 1, 43, 47, and 2021. And from this list, only one is inside the set on our question. So therefore, there's only one possibility that is a factor of 2021. Therefore, our probability will be equal to 1 over 30. Alright, for part B, this is a bit interesting. 2 random numbers are picked simultaneously from the set 1, 2, all the way up to 99 and 100. If the probability that the two numbers differ by 2 can be expressed as a fraction a over b, where a and b are relatively prime, find a plus b. Alright, so first let's just list the possibilities of those 2 random numbers that differ by 2, which will be, let me just write that in pairs. So it'll be 1, 3, 2, 4, all the way up to 98 and 100. Also, it adds all permutations or switches in the pairs or our solutions here in this case. So why is that the case? Because here it says two random numbers are picked simultaneously. So really order doesn't matter right here, because if we write each solution in a different order, it results in a different combination. Since we cannot tell which one is the first number and which one is the second number. So all of these will be the exact same copy, but just switch places. Here we have 2 times 98 or 196 total solutions. Right. Therefore, our probability will be equal to 196 over the total the total number of possibilities for the two numbers. Let's just suppose that the numbers chosen will be A and B. For A, the number choices for A will be 100, since there are 100 elements from the set to choose. Similarly, there are 100 ways, or 100 ways, or 100 possible values for B, since there's again a total of 100 elements in the set to choose. And by the multiplicative law of counting or combinatorics, the total number of ways for our two numbers will be 100 times 100, which will be 10,000. So therefore, the denominator will be 10,000. This can be approached similarly by setting A to be a certain number and B to be possibly any number you want. So let's say we can set A to be 1, B could be anywhere from 1 to 100. Similarly, 2, we can set A to be 2, and B could be any number from 1 to 100. Therefore, we can obtain 100 possibilities from each of these cases until we reach setting A to be 100 and B to be any number from 1 to 100, which will give us again 100. And then we can add all of this up, so our total will be 100 plus itself 100 times, or 100 times 100, which again will result in 10,000. Alright. However, what's the question telling us? We must express this as a fraction in Lowell's terms, or as a fraction in terms of A over B, where A and B are relatively prime. Notice that we can simplify this further to be 49 over 2,500. And this satisfies our values for A and B. Therefore, A plus B will be 2,549. And that's the end of example 3.